Hello everyone, this is Shekhar, Mechanical Engineering graduate from IIT Delhi. Today I am going to discuss very important and interesting topic of physics, that is projectile motion. So whenever a particle is thrown with some initial velocity making an angle theta with horizontal, the motion of this particle under the effect of Earth's gravity is called as projectile motion. So to analyze the projectile motion, what we need to do is, as we know that two mutually perpendicular vectors are always independent of each other. So similarly, the motion in two perpendicular direction will also be independent of each other. So analyzing the projectile motion is through resolving this entire motion in two perpendicular direction. One is horizontal and another is vertical direction. So we are going to talk about the ground to ground projection. So if the initial velocity of the particle is, let us say, u, making an angle theta with the horizontal, and it is entirely under the effect of Earth's gravity. So horizontal motion means the component of this motion along x direction. So initial velocity in x direction will be equal to u cos theta, right? The component of acceleration in x direction will be 0. There is no acceleration. So when there is no acceleration, we can say final velocity will also be initial velocity that remains constant u cos theta. So such motion is called as uniform motion. We can use S is equal to u into t. This formula can be used. Now, if we resolve this motion in vertical direction, that is y direction, in y direction, the initial velocity is u sine theta. Acceleration in y direction, upward direction is taken as, let us say, positive. So ay will be equal to minus g. It is constant. So vy can be written, or we can say it is called as uniformly accelerated motion, or we can call it as uniform acceleration. So we can apply equations of motion. All the equation of motion can be applied in y direction or vertical direction. We can say vy is equal to uy minus gt, or we can say vy is equal to u sine theta minus gt. This is the final velocity, or the velocity at any time t. So first we are going to find out the maximum height attained by the projectile. The height will be maximum when the velocity is having only the horizontal component, or we can say when vy is equal to 0. So we can say sy will be equal to h if vy is 0. So we can apply equation of motion. Vy square minus uy square is equal to 2ay into sy. So by using this condition, we can say 0 minus uy square is equal to 2, ay is minus g, and sy becomes h. So h will be equal to uy square by 2g. Or if we put the value of uy, so we can say h is equal to u square sine square theta by 2g. This expression can also be obtained by using the energy conservation equation, because the only force acting is gravitational force, which is conservative force. So by using energy conservation, initial potential energy is 0. This is the reference, let us say. So if we apply conservation of mechanical energy, initial potential energy is 0 plus half m, initial kinetic energy is ux square plus uy square is equal to, at the maximum height, potential energy will become mgh, and the kinetic energy is only half m ux square, because y component of velocity is 0. So this half m ux square is getting cancelled out with this, and this m is also getting cancelled out with this m. So h will be equal to uy square by 2g. That is what we have obtained. So for theta is equal to 90 degree, if we throw the particle in upward direction, then h will be maximum, that is u square by 2g. H will be maximum, which is u square by 2g. So can we say, because the kinetic energy is minimum, or we can say potential energy is maximum at a height h. At a height h, potential energy is maximum. So when the potential energy is maximum, we can say kinetic energy will be minimum. Kinetic energy will be minimum. And what is the minimum kinetic energy of the particle? The minimum kinetic energy is half m ux square, or u cos theta square. That is the minimum kinetic energy of particle throughout the motion. Also, we can find out the radius of curvature. We can also find out the radius of curvature. Look, for a circular motion, the acceleration, normal acceleration or centripetal acceleration will be v square by r. So to find out r, that is the radius of curvature, we can say v square by a perpendicular. So the acceleration should be perpendicular to the velocity for the circular motion. So if we draw the projectile motion, if I talk about this point 1, here the particle is moving along this circular path, let us say here. Acceleration due to gravity is acting in downward direction. The velocity, initial velocity is u. So this angle is theta. So if we take the perpendicular component of acceleration, perpendicular to the velocity, so we can say if this is theta, this angle will also be theta. So it will be g cos theta. Perpendicular acceleration in perpendicular direction. So we can say r1 is equal to u square upon g cos theta. This is the radius of curvature at point 1. Similarly, we can find out the radius of curvature at point 2 also for this circular path. Let us say acceleration due to gravity is acting in downward direction, and the velocity is perpendicular to, velocity is only in horizontal direction, that is u cos theta. So we can say r2 will be equal to u cos theta square upon g. That is the radius of curvature at point 2. Next, we can find the time of flight. Time of flight. The time taken by the particle becomes time of flight if Sy becomes 0. When the particle reaches to the ground again, then the total time taken is called as time of flight. So again, applying the equation motion, which one? That is Sy is equal to uyt plus half ayt square. So when Sy becomes 0, then uy into capital T minus half g into t square. So from here we can find out t square into g by 2 is equal to uy into t. T getting cancelled out. So time of flight will be equal to 2uy by g. Or we can say the time of flight will be equal to 2 into uy is equal to u sine theta by g. And from symmetry, we can say time taken to reach the highest point is half of time of flight. So we can say to reach highest point, it is t by 2, which is uy by g. These expression can also be obtained by assuming the motion in y direction only, motion under gravity. So 2u by g is the time, total time of flight, and to reach the highest point, it is 2u by g, u by g. Next is horizontal range. As we know that in horizontal direction there is no acceleration and the velocity remains constant, u cos theta, that remains constant. So this is called as horizontal range. So for horizontal range we can say it is u cos theta into time of flight, that is u, or we can say it is ux, we can call it as ux into time of flight. So ux into 2uy by g is horizontal range, or we can write it as 2ux into uy by g can be written as 2. It is ux is u cos theta and uy is u sin theta by g. So it will be 2 u square by g, and 2 sin theta cos theta is sin 2 theta. That is range. For 2 theta to be 90 degree, or we can say for theta to be 45 degree, range will be maximum. Range will be maximum, which is u square by g. And we can also say that for 2 theta and 180 minus 2 theta, these two angles, these are supplementary angles. These are supplementary angles. For them, sine 2 theta will be equal to sine of 180 minus 2 theta. Or we can say for theta and 90 minus theta, range will be same. For these two angles, theta and 90 degree minus theta, range will be same. If we throw a particle at angle theta, this is let us theta, the range will be this. The time taken by the particle is, let us say, the time of flight is t1 and the maximum height is, let us say, h1. And if we throw the particle with the same initial velocity u, but now at an angle 90 minus theta, this angle is 90 minus theta. So the height will be different, maximum height attained will be different, and the time of flight will be different, but range will be same. Because sine 2 theta and sine 180 minus 2 theta will be equal. So from here we can get some important results. Range will be same. So if we write T1 is equal to 2u sine theta by g. And what about T2? That is 2u by g. It is sine 90 minus theta. And sine 90 minus theta is cos theta. So 2u by g, it will be cos theta. So if we divide T1 and T2, T1 divided by T2 will be equal to 2u by g getting cancelled out. It will be sin theta by cos theta, that is tan theta. So we can find out angle theta, that is tan inverse of T1 by T2. If we know the time of flight for both the angles having the same range, then we can find out the angle of projection and 90 minus theta and 90 minus theta. Similarly, if we square T1, so T1 square will be equal to T1 square will be equal to 4u square by g sin square theta, and T2 square will be equal to 4u square by g cos square theta. If we add them, so what we will get, T1 square plus T2 square is equal to 4u square by g square. It is 4u square by g square. 4u square by g square sin square theta plus cos square theta. And sin square theta plus cos square theta is 1. So from here we can find out u is equal to g by 2 under root of t1 square plus t2 square. We can find out the initial velocity also. Similarly, h1 will be equal to u square sin square theta by 2g, and h2 will be u square sin square 90 minus theta by 2g. So it will be u square cos square theta by 2g. So if we divide h1 and h2, so it will be tan square theta. So from here also, from maximum height attained, we can also find out theta. That is tan inverse of under root of h1 by h2. If we add them, h1 plus h2 will be equal to u square by 2g sin square theta plus cos square theta is 1. So we can find out u is equal to under root of 2g h1 plus h2. Similarly, if we multiply h1 and h2, u square sin square theta by 2g multiplied by u square cos square theta by 2g, isn't it? So it will be, if we take u square by 2g and we can write sin theta into cos theta, it will be whole square of this. If we multiply and divide by 2, so u square sin 2 theta by g, this will be the range. So we can say it is r by 4 square. h1 into h2 will be r by 4 square, or we can say r range can be calculated as 4 under root of h1 into h2. This is how we can find out the range also. Next is the velocity. At any time t. So velocity is given by Vx I cap plus Vy j cap. Vx is ux, that is u cos theta. Same. On horizontal direction, velocity will remain same. Plus it will be u sin theta minus gt j cap. We can also find out the angle tan alpha is equal to Vy by Vx, that is u sin theta minus gt upon u cos theta. Alpha is the angle made by the velocity with horizontal at any time t. Now for time of flight, when t becomes capital T, that is 2u sin theta by g, then what will be the velocity? So we can say v is equal to u cos theta I cap, it will remain same, plus u sin theta minus g into 2u sin theta by g in j cap. So it will be g will get cancelled out with g. So v is equal to u cos theta I cap minus u sin theta j cap. What does that mean? The velocity becomes, in y component of velocity becomes negative of the y component of initial velocity. It means when the particle is projected with velocity u here, initial velocity u at some angle theta, so the final velocity v is also u but opposite to the direction. This will also be theta. So for theta is equal to 30 degree, let us say this is u cos theta and this will be u sin theta. Here it will be u cos theta and it will be u sin theta. So for angle 30 degree, if the angle of projection is 30 degree, the velocity, the final velocity with which the particle is hitting the ground is also same u. This is also angle 30 degree. So the angle between these two velocity, we can say from the concept of triangle, this is u, this is final velocity. If this angle is 30, this angle is 30. So exterior opposite angle will be 60 degree. The angle between u initial velocity and final velocity will be 60 degree. If the initial angle of projection is 45 degree, so we can say the angle between these two velocity will be 90 degree. This will be 90 degree because this will also be 45 degree. For angle 60 degree, for angle 60 degree, let us say, if this angle is 60 degree, so this angle will also be 60 degree. This is u. This angle will also be 60 degree. So this angle is 120 degree. So we can say at some point the angle between velocity, initial velocity and final velocity can be 90 degree. So for theta to be greater than 45 degree, there is a point on the projectile where the initial velocity and final velocity will be perpendicular to each other. This is, let us say, v velocity. They will be perpendicular. So we can say for u is perpendicular to v, we can say u dot v, dot product of these velocity will be 0. So what is u? That is u cos theta I cap plus u sin theta j cap, and having the dot product u cos theta I cap plus u sin theta minus gt j cap. So if we take the dot product, so it will be u square cos square theta plus u sin theta, it will be u sin theta minus gt is equal to 0. Or we can say u square cos square theta plus u square sin square theta is equal to u sin theta into gt. So it will be u square is equal to u sin theta into gt. U and u getting cancelled out. So t is equal to u upon g sin theta. At time t, the velocity will be perpendicular to each other. Next, let us talk about equation of trajectory. As we know, x is equal to u cos theta into t. So from here we can say t is equal to x upon u cos theta. And y is equal to u sin theta into t minus half gt square from equation of motion. Put the value of t from here to here. If we put the value of t, then y is equal to u sin theta into x by u cos theta minus half g into x square by u square cos square theta. So u getting cancelled out. So it will be y is equal to x tan theta minus gx square upon 2 u square cos square theta. This is the equation of projectile. Y is a function of x square, so it is parabola. The path of the projectile is parabolic. Or we can also write it as x tan theta minus gx square upon 2u square. 1 upon cos square theta is sec square theta. Sec square theta can be written as 1 upon plus tan square theta. This is another equation. Or if we take common x tan theta common, so y is equal to, if we take x tan theta common, then 1 minus gx square upon 2u square cos square theta then into x tan theta. So sin theta by cos theta. So cos theta getting cancelled out with this cos theta, and so 2 sin theta, 1 x is getting cancelled out with this x also, 2 u, this u square sin 2 theta by g is r. Sorry, not this one. This g2 u square sin square theta. This is r. So y is equal to x tan theta 1 minus x by r is another expression for equation of trajectory. So this is your assignment. Please try to solve this question. So that is all for today. Thank you. Enjoy. Take care.